Hey everybody, welcome to the Permeability and Porosity Lab. We are going to be looking at how water kind of permeates through the substrate in a particular ecosystem. So let's talk about two terms here that we need to know about. One is permeability. Now, this term is really trying to tell us how well water flows through a substrate. So think of it this way. If you have the surface, let me do this in red. If you have the surface of your substrate, right, and you want to see how far down does water go into that substrate, right? How well does water pass through it? That's permeability. Right? So that's permeability. Now the other term we want to know is porosity. Now porosity, we are talking about the amount of, in this case, water a substrate can hold based on the amount of empty space. Now this can also be air in a terrestrial habitat. So if you have, we'll use that red again for the substrate. Let's say we have very kind of big and chunky granules, right? So there's a lot of space in between those granules. See, there's a lot of space water can kind of fit in, right? That is what we're talking about. That's very porous. Now, on the other hand, if we have something that's a little bit more tight, when the grains are a little bit smaller, really tiny, and they're all really close together, right, like that, we're talking about a situation where water is going to have a much harder time being in the middle there of those different grains. So the porosity is going to be much less. Now, when you have a higher porosity, you have water that can permeate through the substrates a little bit more, a lot deeper. So that's what we are going to be looking at in today's lab. So now we're here at the lab station, and let's talk about what we are going to do. So we have three types of soil here. I have sand, which is just basically sand from the beach. I also have some soil, which is actually some gardening soil, so it's got some organics in it and clumpy stuff, as well as some quartzite sand and things like that as well. And then we have gravel. Now this is actually good old aquarium gravel, just to stand in for any gravel that might be out there, larger chunked particles. And so the idea here is we're going to look and see how permeable these three substrates are. What is their porosity different? Now you may draw some conclusions because you can look at these three and go, okay, well, one in your head you might already think has more pores, more porosity than the others, and thus it's probably going to be having a higher permeability. So you're going to mark those down in your lab sheets, those predictions, when you get to that part of your write-up. But that's what we are doing here. Now let's talk about the process in which we are going to work. So you are going to use a very sophisticated piece of scientific equipment, a cup. This happens to be a plastic cup. And what we are going to do is we are first going to measure out 100 milliliters of water using a graduated cylinder. Now I do have a beaker here and a graduated cylinder. One of the things you need to ask yourself is which is the most accurate and why. Those are things that you need to be able to manipulate and discuss in a ACE exam as well. But we are going to use the graduated cylinder because it has a scale on it that's much more refined than the beaker. So it's a little bit more accurate. And we're going to go ahead and pour in 100 milliliters of water. Now, when you're doing that, you're also watching for that meniscus, right? Like I was a little over there, a little under. So there's a little bit of back and forth until I get that meniscus right on the bottom line there. All right, I got it. I'm ready to go. So I'm going to pour that into the cup, and I am going to draw, and I've already done this before, I'm going to draw the line right there at the level the water hit, and then I'm going to put the water back in the graduated cylinder. The reason why I did that is just to get the level there. I wanted to know approximately where 100 milliliters was going to be, because we are going to fill the cup with 100 milliliters of the substrates. All right, now I'm going to take my cup and I'm going to fill my substrate up to that line. I went a little over there, so there we go. Now I'm about to that line. I am ready to go with my one sample. Now, we are not going to just do this once. We're going to do this at least 3 times. So we're going to go ahead and fill up each of my 3 cups. Now, also I should mention, which I might not have, is that there is a pinhole at the bottom of each of the cups, and that is what the water is going to flow through. All right, now we are ready to get going, but I want to start talking about our variables here. Now, we have 3 types of substrates. Now, obviously, you probably have figured out, we are going to find out how fast these substrates allow water to pass through them. So we are going to have a beaker on the bottom of each one, and we're going to pour 100 milliliters of water in each substrate cup and measure how long or how much volume of water in milliliters comes out into the beaker from a hole that we've poked in each cup in 60 seconds, right? That's what we're going to go for. So what is going to be our independent variable? If you said the different substrates, you are correct, because that is what we're manipulating. We are changing the substrates. We are not changing anything else. Now, what is our dependent variable? If you said the volume of water that comes out in the 60 seconds, that would be correct. That is our measurable responding variable. Now, you also have to remember, what are your standardized or control variables? What are the things you want to keep the same for each of the different trials? For example, I want to make sure I have the same volume of water being put into each of the soil cups. I want to make sure we have the same volume of sediment in each of the different cups. I want to make sure that we measure the same time in 60 seconds. So those are things we want to keep the same across the board. All right. So that is essentially our setup. Now, one other thing, we have to do replication, right? So that replication has to occur, and we are going to replicate this at least 3 times. Now, this video is going to show you data for 3 different times. Now, if you are doing it in a class where you have more replication, use that data instead. But let's go ahead and get started. Now we're going to show you some clips of us actually doing the lab. Here we are pouring 100 milliliters of water here in one of the soil trials, and you can start to see the drips come down into the beaker below. And here's a little bit better of a view of that drip, drip, drip happening there. And of course, we didn't just do it with the soil, we also did it with the sand and the gravel. So here is the sand. Here's a sand trial going on. You can notice how it clears up a little bit faster than the soil does, but you have that drip, drip, drip happening there as well. And of course, the same thing occurs with the gravel. Here's an example of the gravel dripping into the beaker after we put that 100 milliliters in. And of course, we're waiting that 60 seconds, and then we're going to terminate and find out what the volume in milliliters of water is. And here is the self-populating graph as all our groups are doing the data collection. They are popping that data in here, and here is the final data set. Now you want to pay attention to the means because you're going to need that to calculate
things further on in the lab. But let's go ahead and check out what the graph looks like in total. And here we are. We see the sand, soil, and gravel. So for our experiment, the gravel had the most porosity, which was probably no big surprise, right? It had the majority of the water essentially permeating through it. The soil actually was the smallest. Now, this had chunks of organic material and a lot of things that probably plugged up the hole as well in the cup. And of course, the sand over on the left side. Because remember, it's just a little pinhole that the water is going through in the bottom of the cup. All right, now you have conducted the experiment, and we're going to show you the results here on the screen if you don't have it from class. And now you get to go through the analysis questions and decide what happened. Did your predictions at the beginning, were they correct? Were they not correct? Were there some nuances there? All those interesting things to find out. So until next time, keep learning.